Thank you very much for joining this last workshop in this STC conference. The workshop is titled Metadata for Matchings, Metadata Templates to support FAIR principles for observational health research. The objective of this workshop is to promote collaboration for better metadata to improve the fairness of health data sets. So our objective is to work with the metadata that is generated in the context of the apply of the FAIR principles. The second objective of this workshop is to prototypical generate templates using controlled vocabularies through the use of CEDAR tools. Below, my colleague John will present an overview. And the third objective is to start working in an outline roadmap to support the FAIR principles using the CEDAR tools. Oh, sorry. This is the table of contents we are going to follow. In a first step, we are going to introduce the FAIR for Health projects because in this project we are working with the FAIR principles with health data. Below, we are going to introduce M4M and metadata for matching previous workshop because this is not the first workshop in this topic. Usually, this workshop needs 2 days to complete the work. But today we are going to work in a rapid M4M workshop. In 90 minutes is a first work in the collaboration between the FAIR for Health community and the CEDAR community. In the fourth point, we are going to see how we can use CEDAR tools to build FAIR metadata. And in the last section, we are going to see different case studies about the use of CEDAR tool for creation of metadata templates. We are going to see 3 use cases. The last one is related to the metadata generated in the FAIR for Health projects. The second one is related to the NFDI for Health metadata schema. And the third one is related to COVID-19 scenarios. For a start, I'm going to introduce all the panelists. By one hand, 3 authors are from the Andalusian Health Service. I am Alicia Martinez Garcia, and I am working in this workshop with my colleagues Celia Álvarez Romero and Carlos Parra Calderón. We act for the research and innovation in biomedical informatics, biomedical engineering, and health economy from the Institute of Biomedicine of Seville, from Virgen del Rocío University Hospital, as part of the Andalusian Health Service from Spain. Our research group are involved in several regional, national, and international research development and innovation projects, and we work very closely with the hospital departments. We work in the coordination team of the FAIR for Health projects. Carlos Parra is the main researcher of these projects, and we are also actively involved in several activities related with some international research organizations, such as the Fire for Fair Health Level 7 project and the Raising Fairness in Health Data and Health Research Performing Organizations Working Group for the Research Data Alliance. Carlos Parra is part of the EFMI board and is member of the American Medical Informatics Association. Other authors in this workshop is Matthias Love and Christian Dreyer. Matthias and Christian are research assistants at the Institute for Medical Informatics for the University of Leipzig. Matthias' main research interests are metadata and metadata repositories, IT support for clinical research, FAIR research data management, semantic interoperability, and standards. Christian is working on his master thesis on the topic of data quality assessment of healthcare data. By other hand, Matthias, on behalf of the Institute, is involved in FAIRware projects. They both are part of the SMIS consortium from the Medical Informatics Initiative and in the National Metadata Repository. And Matthias is collaborating too in the MFDI for Health projects. Other two authors in the workshop are Ronald Korner and Eric Schultes. They are both working in the GoFair initiative. Ronald is from Amsterdam UNC and is part of the FAIRware consortium. Other two authors in the workshop are Mark A. Musen and John Gravel from the Stanford University School of Medicine and from the Stanford Center for Biomedical Informatics Research. Mark is principal investigator of Protege and Web Protege, Bioportal and Ontoportal, and CEDAR Workbench, and John is the technical program manager of CEDAR, Bioportal, and Ontoportal. By other hand, Anil Sinasi is from Software Research Development and Consultancy Corporation from Turkey, and he is part of the FAIRware consortium. And the last author of this workshop is Erika Login. She is from Wellcome Trust and she participates in FAIRware projects. In the last minutes, Erika said to us that she cannot join the workshop due to personal problems. But if any person in the audience need to contact or have a question for FAIRware projects and the rest of panelists cannot answer, we can give you her email and put in contact with her. That's all for the introduction. Now, Celia Alvarez is going to introduce the FAIRware projects.
Hello, thank you, Alicia, for the presentation. Today, I would like to present an overview of the FAIRware project. Here you can see the social network to follow the last news of the project. Firstly, FAIRware project is coordinated by the Technological Innovation Group at the Virgen del Rocío University Hospital as part of the Andalusian Health Service in Spain. FAIRware consortium account for 17 partners from 11 different countries. And this project started on December 2018 and finalized this month at the end of November 2021. FAIRware brings together the expertise of different health research performing organizations, data managers, health research institutes, medical informatics, software developers, standardization, and hospitals and other health research organizations. The main purpose of FAIRware was to facilitate the application of FAIR principles to the data sharing and reuse in the health research domain. Firstly, we have performed a comprehensive analysis to to study what are the requirements, the considerations of health data, because we designed a verification workflow based on the GoFair initiative, but we address the technical, legal, cultural, ethical requirements of health data. So firstly, we designed this verification workflow in the project. Here you can see a scientific open access paper on this verification process that we have followed. So we applied the FAIR principles in health research data set. We designed the FAIR for Health solution following the first step that was this verification workflow. And we verified 5 different data sets of 5 different health research performing organizations. In this process, we have generated FAIR metadata, and this FAIR metadata was published in a published repository that is GitHub. And then when we perform the verification, we could carry out a federated machine learning analysis through the FAIR for Health platform to implement, to perform 2 use cases in the project. So this FAIR metadata generated through the verification was published in GitHub. You can see here the link to GitHub, but today we would like to highlight the clinical metadata that we have generated. For example, in this page, this is the welcome page of the FAIR for Health platform, and you can see the clinical information of the 2 use cases of FAIR for Health project. We can see that for, these use cases have a number of pilot sites and what were the number of patients, the number of records that we analyzed in these use cases. But then we have more clinical metadata because, for example, in this screen, we have info related to the data sets. For example, we can see, we can apply this window. Here we can see for each data set, what is the number of records, and for each variable, for each clinical variable, more detail. For example, for a numeric variable as age, what is the mean and the max, and for the rest of variables, what is the number of male, or how many patients is true that in the smoking status variable. Also, we can see if we click in this blue button, see all distributions. For each variable, we can see more information. For example, for age, we can see how many patients have 18 years old and what is the percentage. This info is for each clinical variable, and also for we can see all distributions of each data set. So we can analyze what is the distribution of our data set before performing these machine learning techniques. Well, in FAIR for Health, our purpose is was to establish synergies and collaborations with similar initiatives with other projects that search in this domain. We created a FAIRware open community too. And I think that this is all for my side. Thank you.
Thank you, Celia. Now, Eric, the floor is yours, please.
Hi there. Yeah, Alicia, you can hear me? Is the audio?
Yes.
Yeah, good audio check. Super. Great. So the first slide here in this section is just to give you an overview of this idea of metadata for machine workshops and the ones that we've been lucky enough to provide so far, and sort of gives us a state of the art of this approach. So in this first slide here, it's just a listing of what we now have, depending how you count, we have up to 18 metadata for machine workshops, which we've delivered. And I'm saying this from the point of view of GoFair and our collaborators at Stanford who have helped us to deliver these workshops.
Sorry.
Yeah, okay, yeah. If you can go back one slide, please.
Sorry.
Yeah, good. And I just have some snapshots here from some previous workshops that we've held. And before COVID, of course, a lot of this was done in person, and I think it was very nice to do this in face-to-face contact. But since about a year and a half ago now, the metadata for machine workshops that we've delivered have been entirely virtual, and we use Zoom mainly for that. So this is just kind of the overview of the uptake of this technique. But let me, in the next slide, try to ground this. What are these metadata for machine workshops? What do they look like? And how is it that we envision using them to increase the use of FAIR data going forward? And so, as I say, this is really kind of an invention of the GoFair initiative. And the thinking was that because metadata, and let's say machine actionable metadata, is so fundamental to FAIR, you see it is really contributing to almost every one of the FAIR principles, that we thought it would be productive to develop kind of a rapid format onboarding type workshop environment where domain experts who may not be experts in metadata and who almost in every case, they're never an expert in machine readable metadata. They nonetheless would like to benefit from FAIR. And so they would, in general, like to have some assistance in making metadata more fair for their domain and for their uses. So in the next slide, in GoFair, we've developed an entire framework around this FAIRification approach. And what I'm showing here is the page from the GoFair website. And you can see where this metadata for machine workshop fits into this overall 3-point FAIRification framework that we've developed. And this is not to say that this framework is the only way to do FAIR, but I think it's safe to say that for any attempt to verify data, you will be touching upon the key ingredients here listed on this web page. But we'll focus today on the metadata for machine workshop approach. So in the next slide, as I say, our starting point is always the FAIR principles itself. And in box 2 here, I take this from the original publication on the FAIR principles. And you can see that, in fact, metadata appears all over the FAIR principles. So you're never really going to be fair if you haven't addressed this machine actionable and machine readable metadata. And on the FAIR principles, at the very bottom in principle R 1.3, I'm also indicating with the green box that there is an imperative to have and to follow domain relevant community standards when building your metadata. So you can see that then translated, the whole idea of a metadata for machine workshop It's pretty simple. We bring together the domain experts, and that's where we can cover these domain relevant community standards. We team them up with FAIR metadata experts. So for example, my colleagues at Stanford, who can bring with them a set of ready solutions and tooling to make this verification of your metadata much more formulaic, straightforward, reproducible. The end result, the end product, the output of a metadata for machine workshop is at the bottom, it's going to be FAIR metadata, which is to say machine actionable schema and vocabularies that fit that domain. We want these to be domain specific. We want these things to be reusable. And so all of this is kind of cooked into the format of the metadata for machine workshop approach. Next slide. So here's an example of a previous metadata for machine workshop. This is an extensive set of workshops that we ran on behalf of the Dutch funder, the ZonMV. And this was on behalf of their COVID-19 research program. And Ronald will be talking more about this later in the presentation in the use case section. So we'll get to more details of that, but it's a large research program. And what we did is we worked with 62 of the projects in this program in a series of 6 metadata for machine workshops, where we really brainstormed with the project PIs, the researchers, and accompanying data stewards. And these were very controlled, very kind of high precision type brainstorm sessions, but it enabled us to generate terminologies and vocabularies that are of relevance to the researchers and their projects at the ZonMV COVID program. And then over time, we were able to consolidate this list of vocabulary and really transform it into a controlled vocabulary in BioPortal. And we were also then authoring a number of different CEDAR templates, one for project administration, one for project content, so kind of a scientific description of your project, and then a generic template for data sets. And those templates were fed by the vocabularies of this group. So now we are, well, I would say, we started in September of this year a process whereby these forms and these vocabularies could be used for all 130 projects in the COVID program. And I think we have over 100 of those projects now that have completed metadata for their projects and for some of their data sets. And interestingly enough, this FAIR data is now available, this metadata is now available on the Health RI portal. This is a Dutch organization devoted to information and health sciences. And in the next slide, you can see kind of a summary of this very extensive process. We first built vocabularies, which are now in BioPortal. This was able to feed templates that we built as a community, and those templates now are being completed to create metadata instances, which become searchable and findable in the Health RI portal. And I have links here if you want to see all these things. In the next slide, this was a very extensive kind of really from the ground up creation of metadata and vocabularies for this group. In the meantime, we've also refined what we call the rapid M4M. And this is a one-day workshop, or roughly 6 hours workshop, where we come into this workshop with the data set metadata template as a given. So we kind of bring this template ready-made. It's based very much on DCAT with a few variations. And the main effort or activity in the workshop is working with that particular domain to build vocabulary. And that's vocabulary for 2 fields in the metadata templates. It's an overall subject heading for the data set, And then it's also a variable description. So what are the actual measurements or observables that you have contained in your data set? So this is really kind of an introduction to or training session with some tooling, but it's a rapid style event, and this is becoming very popular now. A lot of groups that want to kind of dip their toes in the water of FAIR very much like to start with this rapid M4M approach. Our next M4M, as a matter of fact, number 19 is coming up in December with the Nordic, EOSC Nordic group, and they'll be focusing on climate data sets. And in the next slide,
Eric,
I just wanted
1 minute more, please.
Yeah, no problem. So just
Okay,
two more slides here. So in this slide, I just want to give a sense that the metadata for machine workshop, any particular workshop is not really in itself as the end goal. The idea is really to figure out some methodologies by which we can really scale the production of FAIR metadata. So scale the production of domain relevant vocabularies and try and get them into a practical usage as easy as possible. So for example, the metadata templates that we may hear about later that have been created in FAIR for Health, these templates and the vocabularies can be reused by others who come along, who may have similar concerns. And so what I'm showing here in this diagram is that we have a series of different communities that may run metadata for machine workshops, and they could very much draw on the work done by other communities, previous communities, in creating their own metadata assets. And finally, in the last slide, I just wanted to mention that very much we see in next year, we will be focusing on train-the-trainers, meaning that we would like to begin training people to run metadata for machine workshops using some of the methods and tooling that we've developed. And if anybody out there is interested, we would be very happy to hear from you. The bottom line is the metadata for machine workshop is really intended to be a way to fast track the onboarding of FAIR metadata. And just to be strictly speaking, I think what we're doing today, I would not call a metadata for machine workshop per se. This is a nice webinar about metadata for machine workshops, but we really want to preserve that idea of a workshop environment as something that creates a schema and creates vocabulary. Thank you.
Thank you very much, Eric. Now, John is going to introduce the CEDAR set of tools. John, are you here?
I am here. Can you hear me?
Yes, perfect.
Most excellent. Thank you. Can you let me know what time I should finish at to bring us in on time, so to speak?
Sorry?
What time should I finish by so I can calibrate my
you have
presentation?
25 minutes for your section.
Okay.
Okay, thank you.
Okay, thank you. Got it. Yeah, I'm here to talk about this, basically about CEDAR, and give you a quick idea of what it involves and how you can use it to create FAIR metadata. Next slide. The problem that we faced that caused us to create the CEDAR workbench was that in the biomedical community, there were solutions for metadata. There were minimum information models which described things textually, and there were Excel spreadsheets that people could fill out. But the minimum information models weren't computable. They were just descriptive, and so people didn't follow them consistently. And the Excel spreadsheets didn't really include semantics in them for the most part, and they weren't easy to validate, especially in real time. And these solutions were just hard to use. Next slide. And so we understood how most metadata gets created. It's investigators are performing experiments, and some project authority creates a template that can encourage good data annotation to describe those experiments. And so the investigators fill out the metadata using the templates, and the project stores that, and the researchers can use the results. So we thought that we could find a better way to support doing this. Next slide. So we wanted the metadata to be simple for the metadata providers, and especially for the metadata providers, and yet make it meaningful and computable for all the other users who are going to be using that metadata downstream. And this is really the FAIR vision as well, to make this metadata findable and accessible and all of those good things. And so with funding from NIH's, that's the US National Institute of Health's Big Data to Knowledge project, we started working on CEDAR and have been working on it since then with at first 5 or 6 people, and more recently 1 or 2 people, but soon to be 4 or 5 people again, I think. So we were going for this simple life of metadata. Next slide. So we designed and built an open source system that makes it easy to specify the metadata forms. We call them metadata templates, and even easier for users to fill those templates out. And we'll talk about this workflow, but it's basically the authoring process we talked about, the annotation process, and then the metadata becomes available in a repository or can be exported to other repositories. Next slide. We used the bioportal ontology repository. Sorry if this is a little small. It's in the red circle at the right, the red square at the right. We used it as a community resource to provide the precise terms to fill out the fields. It has over 600 biomedical ontologies in it, another 500 or so ontologies from other disciplines. And these provide the precise semantic content that you need to really fill out fields in a way that 5 or 10 or 20 years later, a person in your field or in some other field can find it and understand what it means. So we made it easy for authorized users to access the system and see this metadata or even update this metadata, not just via user interface, but also via the publicly available REST API. Next slide. And so this last piece that we added was to publish content to repositories or to the open web as people wanted. They could either build their system around CEDAR and use the APIs to pull the information into the external repositories, or we could add software in CEDAR to push the data to the external repositories. And we provided this concept called OpenView. The example you see here is of the generic dataset metadata template that you will hear mentioned elsewhere in today's presentation. And that's available on whenever you publish something via OpenView with CEDAR, anyone can access it. It's a public resource on the web. Next slide. So what I'd like to do now, if it's possible for me to share my screen, is give you a little demo of what CEDAR can do and give you a feeling of how it works. Shall I just hit share screen? Is it possible for me to share my screen?
Sorry?
Is it possible for me to share my screen in order to do
yeah. Yeah. Oh.
If it's a problem, we can I can wing it a little bit, or we could come back to it later on in the presentation.
I think that now you can share your screen.
I think I can.
Press, please?
Yes. All right, so you should be seeing something that now looks like CEDAR. Can people see that all right? CEDAR presentation? I mean, a CEDAR display? Great. So this is what you might see when you've worked on CEDAR a little bit and you've logged in. This is a demonstration user that we've created. And you're looking at the workspace of that user. It's not, it's something like Google Docs perhaps, or other current displays. And I'm going to start by giving you an idea of what filling out metadata is like in CEDAR. And for this, I'm using a collection. We had a collection of metadata, just 40 or 50 examples that we pulled from the NCBI repository called Biosample for biological samples. And so we're going to populate this NCBO biosample template. And so we click on this biosample, on this populate tab. You can see there are a number of fields about diseases and tissues and so on. And so really all the user has to do is click in the field. And because most of these have been populated with controlled vocabularies from BioPortal, there are suggestions being made. And we're going to pick one of these suggestions, hepatocellular carcinoma, type of cancer. And then we'll go to the next field. And the system supports autocomplete. Of course, if I start typing something, I'm going to get the remaining choices. You can see that some of these suggestions are moved to the top and have percentages by them. What the system is doing is, it's first of all going off to BioPortal and saying, where's my content to fill out this field, and looking up all the things in a particular branch in BioPortal. And then it's also saying, are there any other examples of people filling out this form and having filled out hepatocellular carcinoma in the first entry, now wanting to fill out this entry? Are there a lot of examples that give us an idea of what they might want to fill out? And if so, I'll suggest those. So we've both ensured that they're providing a very specific entry that is tied to a specific term in BioPortal that can be looked up later, and also suggested what entries they might want to provide according to what they filled out so far. And so we can continue on down and fill these out, and it works in any order using whatever has been filled out before. It says, I think most of the people with this issue are male, or with these kinds of entries have been male in the examples you gave me. And of course, some forms are just plain text and can be filled out with the appropriate numbers and so forth. And so if the user saves that, now it's been stored to the CEDAR repository. And the thing I want to show about that is you can actually look at the metadata that you've created. We store it in JSON LD. You can also look at it in RDF. These are forms that support the semantic content. And if we look for the term that we entered and search for it in the metadata, we can see the label that the user was seeing, but we can also see the unique identifier that corresponds to that term in the BioPortal repository, and in this case, the disease ontology. And so this is the way that we are controlling in a much more precise way the meaning of the metadata that's being filled out, which is really essential if you want to actually interoperate with the data and analyze it later. If someone's just typed in something and they type in hepatocellular carcinoma, and you're not entirely sure if there might be something else that isn't hepatocellular, and you have to write the software that figures out that hepatocellular is the same as hepatocellular. So all the typos and all the other issues associated with using different terms and so forth are eliminated because we're making it easy to make these controlled vocabulary menus that people are choosing. And it's easy to create a template as well. I'm going to just very briefly give an example of that and show a little bit how you might want to start creating a template like this. If I want to put a disease in my terminology and I want to say, but I want to choose the contents of how they fill that out from BioPortal, I click on the Add tab. It's going off and searching for all the occurrences of disease in BioPortal. And it comes back, not surprisingly, with a lot of matches. There are a lot of biomedical terminologies there. And so we can select any of these. Some of them are just individual terms. Some of them are from whole ontologies. And if we aren't sure which is which, we can show the details, and it brings up the other terms in that neighborhood from BioPortal, and lets us display what's inside them, and we can say, ah, that looks like the kind of diseases I wanted to capture. I'll choose that branch, and I can add that as the terminology that I'm interested in. And we have all sorts of other capabilities for adding other kinds of survey question type results, as well as searching the elements that other people have created and the fields that other people have created. If we wanted to add an address field, for example, we could type address, and part of what we'll see back is a lot of different things. All of these are common data elements that have been provided from the National Cancer Institute CADSR project. There are about 60,000 individual common data elements, also known to us as fields, that you could choose from and actually incorporate into your repository. So into your template, sorry. So let me ask that. And the last thing that I want to show here is, if my time is okay, yep, is the fact that we're able to do a lot of different things with the information we have here and the tools that we have here. We can actually share any of the resources that we own. We can make copies, of course, and move them around just like Google Docs. So the sharing lets you work with other individual people or with other groups, where the group may be anyone that you have created. You can create your own groups, or it can be an existing group in the system. And they can read the, it can be shared for reading or for writing. And I mentioned earlier this ability to share in the web. We'll use back to the demo user. So the generic metadata, this is a copy of the generic metadata template. I'll show you what that looks like here first. This was a template that was created for generic data sets as part of some of the work for the M4M workshops. One of the people who was participating in those had this need in order to create metadata for data sets. And it follows very closely the DCAT standard, which is a standard for metadata for data sets. And as much as possible is following faithfully the specific content as appropriate. And I won't show this in any great detail, but I will jump over and show what the same thing can look like in the open view. So this is a view of all of the different fields that are in that generic data set. And it has the ability, if this were an instance, metadata instance, we would be able to look in the bottom at the content of this and in the same way I did in the main system. So it provides a lot of details about the data set and the fields, and makes it possible for you to share your content with anyone else. I will stop sharing now, and we can return back to your presentation on your side. The final slide that I show is references. I'll click twice to get through that part 4. And one more again, and you'll see the references for CEDAR. You can actually give yourself an account on the system by going to cedar.metadatacenter.org and trying it out anytime. There are large numbers of references of all different sorts. All the source codes on GitHub, of course, and the documentation. And if you want to find more references, just go to metadatacenter.org/references, and you will see, as I think, everything your heart desires in terms of understanding how the system works. I have a question that I'll go ahead and answer if I have time. I think I do. it says, could any ontology or terminology listed in BioPortal be used to provide potential value sets for metadata elements using CEDAR? Yes, and anyone can contribute any terminology to BioPortal in order to provide value sets. Can terms from multiple ontologies be combined to one list of values for a given element? Yes, CEDAR lets you choose, basically you can click on that add button as many times as you want and pull branches or individual terms or whole ontologies as many times as you want for a particular answer. And you can also even choose to ignore certain values from the ontology and have them not be presented, or move certain values to the front of the list of terms to be presented to the user. So it's quite flexible and agnostic. I know it says BioPortal, but the terminology server is actually open to any kind of ontology that will help you do your research. Thank you for that great question of things I should have said. You're welcome.
Thank you very much, John. I don't know why I didn't receive the message in the chat until now.
It's all good. We're here.
I can see. Okay. Thank you to answer the message in the chat. In my opinion, we have a lot of functionality to use with CEDAR tool with metadata. It's very interesting. And now, finally, in the workshop, we are going to show 3 different use cases that we are working with this set of tools. The first one is related to FAIRware Health project. Christian is going to tell us. Please, Christian. Yeah.
Yes, hello. So I will talk about how we could use the tools that we just saw for the metadata generated in the FAIRware Health project. We already got an introduction to the FAIRware Health project, but just to quickly recap, the FAIRware Health project aims to make clinical data from different sites in Europe available for research. There were 2 use cases already carried out doing this, and for testing the CEDAR tools, we limit ourselves to one of those use cases because all the testing that we did was done manually and not automated yet. And each of those use cases captures more than 50 variables on various data sets. So we just take one data set from the FAIRware Health use case 1 and focus on a handful of variables to keep the testing a bit shorter. Okay. Yeah, so the first thing that I got when I got involved in the FAIRware Health project was this Excel sheet on the right that captures FAIR query and FAIR path expressions. Because in the FAIRware Health project, the common data model is implemented as FAIR profiles. And with FAIR queries, you can search for a specific FAIR resource and then use the FAIR path expression to actually select data from it. So if you want to build the data sets at different locations based on the same FAIR path and queries, then you need to share those. And that is called a feature set in FAIRware Health. Those feature sets are shared to the FAIRware Health portal, and that is currently automated there. So each local agent can then create a data set based on the same feature set and the same eligibility criteria. Yeah, but if you want to make those feature sets available outside of the portal, then before we had this Excel sheet, and we looked at how we could possibly better represent this in CEDAR. On the next slide. Yeah, so the very first step we took was to just recreate this kind of table view that we saw before. And the templates and the exemplary metadata, we made them available through CEDAR OpenView, through the links there on the left. And in CEDAR, as John introduced, each element contains different fields and each template contains different elements. To kind of generate this table view, we had to make an element with a field for each of our rows and then add multiples of the same element. And then we get this kind of nice table view that looks the same as before, kind of, I hope. if we look at those FAIRware queries a bit closer, we see that they select the FAIRware resource condition and then look for a specific code. Those codes that they're searching for are ICD-10 codes. So on the next slide, we kind of added those codes to our templates through the bioportal with CEDAR. We can then add through each field in our template. We can add the control term, in this case the ICD-10 terminology. Yeah, we get this little search field. We search for the ontology, and then we could just select our codes and add them to it. This information was like not present before in those Excel tables. And how this looks as a template, we see on the next slide. Yeah, there on the right, you see how the template changes. We kind of don't get this nice table view anymore because we needed to add the terminology for each element on the template generation. So we don't get this table view anymore, but because we did it in CEDAR, we get everything as JSON LD and RDF as well. Yeah, those are also like easily shareable again through OpenView, and the links are included here. Yeah, so this was the effort that we did for the feature sets, and those feature sets were then used to generate the actual data sets. And we already in the introduction, we saw the metadata for the data sets. So next we kind of tried to also capture this in CEDAR. Here you see the overview slide for the project metadata that we saw initially. And on the next slide, you see what we used to capture or try to capture this in CEDAR. Yes, so we tried to reuse resources that were already available, and we used the generic dataset metadata template, the GDMT, that was introduced by Eric and John already. So this was a very extensive template that we kind of shortened a bit for our use case here because we were just testing things out. On the next slide, you'll see what we kept. Yeah, as I said, we kept not that much from it. We can add this back later because you can add all the elements that were created there back to your templates. And we added as well the eligibility criteria for our data sets, which are those FAIR path and FAIR query expressions that we added, I showed initially. We didn't add the whole feature set metadata here because it's better to just include a reference to it and handle that in a different CEDAR template, I think. And the thing that we replaced from the GDMT is how the distribution data is captured. And we look at that a bit closer on the next slide. Yeah, so those templates again are available through OpenView, and on the bottom, this is the distribution data that we already saw at the beginning. The top one is what we captured in CEDAR. So yeah, again, this was done manually for this case, right? But this could easily be automated through the CEDAR API. And on the right-hand side, you would see how this is represented in the CEDAR elements. Okay. In conclusion, CEDAR allows us to easily create manual templates and then kind of evolve them as we go along. So we saw that we made this very quick table that we then could add codes to later, and that all the time we could work at this collaboratively and share it in OpenView and have it available in JSON, LD, and RDF. And ultimately, we can possibly automate this whole process through the CEDAR API. For the FAIRware use case specifically, we can use CEDAR to add the ICD-10 codes to the feature set metadata, which is currently not available in that form. And we could build a repository of distribution metadata for our data sets at different points in time. So because for FAIRware Health, the data sets on each location are built upon clinical data. Ideally, that data grows over time, which might change the distributions in the data sets. So we could use those templates to automatically track how that changes over time. Okay.
Okay, thank you very much, Christian. Now we are going to review the second use case. Matthias, please, the floor is yours.
Thank you. So the second use case that I will present here is the second use case in this workshop, not the second use case of the FAIRware Health project. I have to emphasize on that because the second use case is utilizes the NFDI for Health COVID-19 metadata schema. And those of you who have followed the STC program in the morning, and they already know about it because there were 2 presentations, but maybe not all of them of you have. So the NFDI for Health is a part of the national research data infrastructure, and we are focusing on personal health data in Germany. So there are other NFDI consortia, and it's a very large project, currently 5 years, but maybe 10. And Germany invests a lot of money in a sustainable research architecture. But health, of course, is a primary topic as always. So we do not collect data, but we want to make existing data accessible, but not only, or what means medical data in this sense. We have the epidemiological cohorts, the clinical trials, the public health surveys, and administrative databases. And of course, there's a strong topic here. We had a frontrunner project called the COVID-19 Task Force, apparently because of the COVID pandemic. And it's a sub-project. I only mention it because it's, the financing part for this, what I will present now. The COVID metadata schema is an inventory of COVID-19 studies. It's the semantic basis for representing studies, not only trials, but also other forms of research that were currently done in Germany to address the COVID pandemic. And as a result, only to be short, we have a study hub. It's linked, so you can later follow these links. And it consists of a search portal, a document portal, and an instrument portal, which means you have a central graphic user interface where you can select certain terms or identifiers that you already know. And then you get additional references to documents like annotated case report forms or study protocols. And you have what we call instrument portal, a view on the variables and items that are part of the data collection. For instance, if you want to know who has data for people that smoke. So as I said before, we are trying to focus on metadata standards. So when we developed the schema, and a lot of people came from different disciplines, we were influenced by standards like Dublin Core Datasite, Bridge, or FAIR, but of course also from existing international trial registries where, of course, most of these studies are already registered. Here's a short view on the graphical user interface where you just enter your term and get all the results. I will not go into detail for this. As I said before, there was a presentation of Johannes Darms, and you can look in the proceedings about it. But finally, our metadata schema was developed in Excel, as any good metadata schema is, because it provides a very easy way and everybody can participate from the first minute because everybody knows the tool. And then, of course, we try to map some hierarchies, add additional attributes, use color to emphasize certain things. But if you have a certain amount of items and a certain version that is somehow stable, of course, you will try to implement it in software, and then you cannot make changes so easily. And it's more and more complicated to get, for instance, examples filled in from other people, because there are a lot of items to be addressed. So we look for a way to better handle this issue. And so we looked into the CEDAR metadata workbench, and CEDAR allowed us to create forms consisting of high quality data elements that correspond to the data elements in the Excel sheet that I just showed. And it has a graphical editor, as we have seen before, and it supports collaborative editing. So it looks like quite a nice tool. We first defined all of the basic data element as CEDAR fields. And you can see it on the right side. So every line in the Excel sheet is a CEDAR field. Currently, we have 109 fields. So it's something that we really, as a participant of the project, are on a stage where it's not so easy to know all the fields by hand. So, and then we built some complex data elements. So for instance, you have multiple values or you have combined values that logically build on each other. This would be realized in CEDAR with the elements artifact. And finally, you can build templates as has been shown before. And these templates are by default internally visible, but you can have an open view. They are rendered a bit nicer than the internal view, in my opinion. And then you can present it to other people. And additionally, you can you populate these templates, which means that you get a template view where you can fill in example data. And this is, of course, a very good feature for rapid prototyping, for testing if your community understands what you're trying to achieve with the schema, to get reply on certain elements or value sets. And so for us, it seems to be a very good solution to continue developing the schema. Yeah, I think I have to repeat some of the arguments that were made before. When you realize such a schema in a software tool, of course, you get some ambiguities that Excel will not address apparently at your hands. That means you have to make some decisions which might be regarded as a bug in the schema, and we could reply these things to the original authors of the Excel template. Of course, yeah, CEDAR is help there. And we could also think about how to use the JSON LD and RDF serialization. Currently, of course, we have a JSON API for our use case, but it's not the same JSON that CEDAR provides. So maybe we could reutilize some mapping also. This is currently in discussion. So, yeah, this was the last slide. Thank you. And we could. Okay, yeah.
Yes, so I'd like to follow up with the third and last use case on working with the CEDAR tools. And this was in the context of a Dutch project or Dutch program. A large funder in health and healthcare research had a COVID-19 program with a total budget of 150 million euros. And the important thing there, I think, is, well, a couple of things. First, that it wasn't in isolation, but was done in cooperation with the VODAN, the GoFair Viral Outbreak Data Network, with WHO and with HealthRI, the Dutch Health Research Infrastructure. And that it was not a program about just funding COVID-19 research, but that the FAIR principles in that research were explicitly addressed. Can I have the next slide, please?
Oh, I think I killed Ronald. Wasn't my fault.
I was muted. Was I muted all the time?
No,
Oh.
just by changing the slide.
Oh, strange. Okay, thanks. Thanks for noticing. So to quote the website for the COVID program, it's about open science, open access, and fair data. Well, in line with an international statement, all data and results must be published without embargo immediately in open access form and in accordance with research data management and stewardship, so that all data are fair. Then they say, well, basically they have some information about what's open science, open access publication. But I think the bottom line is that so that all data are fair. Next slide, please. And well, it was about the application of fair data stewardship and fair data management, so that all these data being collected in the context of COVID-19 can be made reusable for the entire community. And, well, preferably computer readable, so that we can also apply artificial intelligence methods on such a big data set. And, well, for that, we will have to use infrastructure, standards, technologies that are specific for research into COVID-19. So it really bridges from being as generic as possible, as fair as possible, and as apt as possible towards research on COVID-19. Next slide, please. So what they did, and I think that's quite impressive, there were a total of 130 projects funded, and they all needed to make their data fair. So you couldn't just say, well, okay, I promise we'll do that, but they had a centralized process in place so that the metadata for all these data sets would be captured. And that was done through 3 templates. And I will not go into detail on that now to keep some time for questions also. A project admin template, a project content template, and then, as you saw earlier, the GDMT, the generic dataset metadata template, which, by the way, is now being replaced by the DCAT templates. So this helps to establish the metadata for those 130 projects in an as much as possible homogeneous way. Vocabularies were created, as you heard before, using a bioportal in which there was created the ZONMW COVID-19 vocabulary, and then all metadata was collected and deposited in CEDAR, as was demonstrated by John. Next slide, please. So, well, this basically took a year. So you could say, as opposed to Eric's rapid M4M in 6 hours, this was really the slow M4M. And here you see there was a Slack channel, and well, this was Meike from ZONMW, who would basically bi-weekly send reminders saying, hey, there's a Zoom session coming up where you can ask any question that you may have on November 1st, on November 16th. And well, as you can see now, we're wrapping up. So that was just 1 or 2 weeks ago, last session to fill in the forms. So that now all projects should have specified their metadata in CEDAR. Next slide, please. And it's not just CEDAR, it is also through the API that was mentioned before, there's this possibility of extracting the data, and it's shown here in this Dutch Health Research Infrastructure website, where you see, so basically now it's 105 projects for which the metadata is being described. And you see here a list of the first 25. And on the left-hand side, for example, that you can filter by the lead institution. And if I can have the next slide, please. So this provides a way of filtering and browsing through the projects, and also a dashboard to provide insight in the data being captured in these various projects. So this dashboard is updated frequently. I honestly don't know if I guess this happens real time based on the metadata. So the age categories that are covered and the number of patients in it. On top, we see total number of patients included and the extent to which they are COVID positive, number of patients on ICU, number of diseased patients, the number of centers that are participating, and gender distribution of the patients. So this is really where we go beyond metadata and have a first aggregated view on the data in all those project data sets. Next slide, please. So, well, basically we worked with these CEDAR tools and well, GDMT and now DCAT templates. Well, that really helps to get your harmonized descriptive, your dataset metadata, and get it deposited in a centralized way. And the API enables the processing of those metadata and visualization, like on the HealthRI portal and dashboard that was shown. And well, basically, I think we can say the metadata have been made fair. They are findable. They are accessible, as the metadata should be. They are interoperable through the use of these bioportal vocabularies, and they are reusable as you see on the HealthRI portal. And well, the aim that all data are made fair. I think we can now say, well, at least all data are made findable. And the extent to which data are well accessible, of course, also depends on the type of data. So there is sensitive data which will not be accessible, but for which then the access conditions or the inaccessibility of the data will be explicitly described. The level to which the data is interoperable is definitely something that needs further attention, because I think in the specification of data sets, there has still been the possibility to diverge. And I think one of the areas where also some more attention will be needed is on reusability, so licensing and reuse conditions of those data sets. But I think all in all, it really shows that a collaborative effort in collecting large-scale metadata really contributes to such data being made reusable. And with that, I conclude this use case. Thanks a lot.
Thank you, Ronald. Okay, give you the floor.
Yeah, thank you very much. All
We had some
presenters.
questions in the chat.
Yeah, John, you propose in the chat, take it into account that Erika cannot be with us in the last minutes, that you can introduce the FAIRware project goal briefly. If you agree, please go ahead.
Sure. I will. I was hoping if you let me share my screen, I'll share one document that may be helpful. And I was hoping to find another, but I couldn't quite do it, so I'll just talk to it.
You can share your screen.
Thank you. And so the Wellcome Trust project, from which some of this inspiration came for the material you saw today, was called FAIRware. And what they initially had asked for, were looking for, was just software that could test that metadata was in fact fair, that could perform evaluations for metadata being fair. And Mark Musin at Stanford proposed something slightly different, which was a method of, it was basically CEDAR, enabling CEDAR early on in a workflow to enforce both the desired community formats for the metadata, and also potentially transform that metadata that they maybe already had into a format that could then be evaluated for fairness. And in our case, we focused not so much on did it pass the 14 fairness principles, which are somewhat ambiguous and somewhat specialized, but did it pass the validations that we thought were appropriate to make metadata actually findable and accessible, make the data findable and accessible, and so forth. And so I'm sorry, this isn't my best slide to represent it. It is an earlier one that is useful to talk about the process. What we propose to do and are in the process of doing is to take metadata that is in some standard format, for example, from Dryad, which is a format following DataCite, if I'm not mistaken, and be able to look at the metadata, see what template may be appropriate from CEDAR for representing that metadata. So we see that a little bit in the top part here, where there's a template suggestions page, and we can suggest different templates. So if in fact it covered all of the material that's in the generic dataset metadata template, that might be a template that you would choose and describe. And then we can look at performing the alignments on that metadata that find fields that have common elements or common labels, shall we say, or can perhaps be represented with particular fields or CDEs or elements that are already in CEDAR. And so the user could shepherd that process and choose which are the appropriate fields. And then having done so, we would be in a position to convert the metadata itself and compare it to the expectations that we would have for that metadata if it's represented by a CEDAR template. And if we found fields were missing, we might be able to impute them to calculate them based on other fields or suggest answers based on other fields. But we could certainly highlight it and say, okay, that's an issue. And part of the vision here is that in addition to identifying sort of the common issues, this is misspelled or that is not from a chosen vocabulary or whatever, we could also collect the metadata from an entire project or an entire funding institution, as was just presented a little bit earlier, and could review all of that metadata from across all of the metadata that's been supplied and actually see which fields are not being filled out as well as they should be. Maybe there's some problem with the descriptions in the fields, maybe the format that's being offered isn't quite appropriate, etc. So we're essentially covering all the bases here. We're trying to help individuals say, oh, is my metadata good? What can I do to fix it? But also the group that is asking for or collecting all this metadata could look at these results and say, it looks like everybody's happy to fill out these other bits, but they're not happy to fill out these fields, and they fill out these other fields here wrong. So we can go zero in on those and improve those relatively easily. And that was the vision behind the FAIRware workbench that the Wellcome Trust has funded, and we're about halfway through that. We actually have a much better UI than this, just in a wireframe, but I couldn't bring it up in time, I'm sorry. But in another 6 months or so, we'll be near the end of this round of funding. And it's our hope that we can find a little more funding to go past this proof of concept stage. And so this is a part of this project has been to identify communities like Fair for Health that are intrigued by the possibilities and interested in perhaps adapting and adopting some of these services for them. So thanks for letting me describe that. I'll turn it back over to you.
Thank you very much, John. Thank you very much, all. I'm going to share again my screen. Okay. To finish, we would like to ask for the audience if you would like to continue in contact with us related to metadata for machine, Fair for Health, FAIRware. If yes, please complete this Google form to send us your name and your email address to contact with you in the future. I'm going to copy the link in the chat. Thank you, Eric. In my opinion, the CEDAR set of tools offer a lot of functionality that is need to work with metadata. Metadata is one of the aspects of the main aspect of the FAIR principle. So I offer to the FAIR community to consider collaborate with you, because in my opinion, it's very useful. As part of FAIR for Health consortium, I can say that 3 years ago, when we start working on the project, we work with this approach. We need to cover metadata. In my opinion, in the future, we can try to integrate with CEDAR tools because we have a lot of functionality to use. We will consider. I'm going to review the chat. I don't know if we have any question from the audience. We have 6 minutes for questions. If someone has question, please use the question and answers part of Zoom. I think that we have only reflections in the chat. For example, John said using CEDAR helps resolving ambiguities in the specification. You think that all the time? Yeah, I agree with you. Yeah, Eric include more information related to the COVID-19 scenario. I would be a great test of FAIR to check interoperability between the CEDAR metadata created in the THOM COVID-19 program that Ronald presented with the metadata created in the experience that Matthias presented. I don't know if by allusion, if Eric, Ronald, Matthias, would you like to add some detail? What do you think? Matthias,
I think that our approach needs a bit more work on semantic foundation with terminologies to really be exploitable. We started because the reference was an Excel sheet. I could not assume that certain fields and standard fields, if I would have done it on my own, I had initially selected bioinformatics intelligence as value sets for certain options. But I think if we improve our current approach, then it would be useful to check if the answer are.
Yeah,
currently it's a bit.
Ronald, could you hear well Matthias? Because we have problem with the external microphone. I'm not sure if
it's a bit, it sounds a bit remote, so it's a bit hard to hear, but yeah.
Yeah, maybe we discuss it later.
Yeah.
Yeah.
Matthias said that you could discuss later. Okay, thank you.
I clearly heard him say semantics are good.
Yeah, and I think so. I think that relates also to John's comment in the chat on how CEDAR and really doing the work helps to resolve ambiguities in specification. I think it's typically the kind of things that people always think, okay, and in the end we try and make things fair and we add semantic to it, only to find out that you wish you would have done it earlier. So and I think all these efforts that we've gone through with CEDAR, but also in FAIR for Health, I think that really shows the importance, indeed, as you say, to well start from semantics, because that really helps to get things sorted out.
Yes, thank you. Other future work or other concern that we have on mind is can we work in a list of milestones to have to work in a FAIR certification roadmap for CEDAR? I don't know, for example, John or Eric, if you could share with us if you have this kind of work on mind. Or
I understood you to say a set of milestones to work with CEDAR in going forward. Is that what you were asking for?
I'm asking is, do you think that you need to continue working with CEDAR, improving CEDAR to work with FAIR principle, or for you?
There is a good answer to that, which is that we know from working closely with Eric and the team that he has a co-FAIR on their FAIR principles and the tools that they've done as well, that CEDAR is very close to being capable of representing solutions in a way that are fully fair and check off a large number of the principles. It's often a function of the template that you create. And we can create a template now that is capable of being converted into that. What we'd like to do is do the final touches to make the template more directly presentable, the metadata more directly presentable, to fully check as many of the boxes as possible. So there's a little bit more work planned on that, and it'll likely unfold over the next 6 to 12 months. But even now, we've we've done it just with some additional transformations done as a follow-on.
Yes, here, Carlos Parra. In this sense, I don't know if can be interesting develop some functionality related to implement the new concept supported by GoFair, like fair implementation profiles, or also directly fair digital objects. I don't know if you try to work in these lines.
Yes, no, it's very much something that we have wanted to do for a while, and we just haven't had the resources to allocate to that particular thing. But we've talked to Eric numerous times about that, and still hope to do it before too long.
Indeed, this is a great topic, and you know, one of those conversations that John and I have had with our colleague and collaborator, a guy named Nicola, who was working at the Danish E-Infrastructure Corporation for a while. You know, who is, by the way, Nicola is the author of the GDMT, the Generic Dataset Metadata Template. And just really quick, you know, one of these lines of discussion have been, you know, the GDMT is a general purpose description of data set. In that way, it looks a little bit like what people talk about in the FAIR digital object space. So is there some minimal core metadata that we'd want to keep that might be generic to all data sets, regardless of the content? And if so, would this minimal information, minimal metadata through CEDAR be a way of building a kind of digital object so that people could deploy digital objects, or let's say data sets as digital objects, primarily by launching CEDAR metadata instances?
Yeah, please contact us if you're with the survey or directly if you're interested in following up on that.
Yeah.
That would be really nice.
Thank you.
Thank you. We have a question in the chat. I think we can use 3 minutes more from the break. Martin Golebieski asks, the system integration workflows at the CEDAR website are not yet described. Will this become available soon?
I think you're referring to the user manual, and now that you've asked, I'll put that as high on the list as I can. We have some slides and examples, and I would be happy to respond to any needs you have to see some of those or get an overview of that. Again, maybe a good way to get in contact is through the form or through Alicia. That would be great.
Okay, Martin, thanks in the chat. Thank you, John. Thank you, Martin. To finish, Eric asks us how FAIRware Health discovered CEDAR. Eric, if I remember well, the connection was through Venkat?
No?
Mark Wilson.
Through the advisory board, yeah.
And I might say hi to Carol Gobu, who was on the advisory board for CEDAR.
Yeah.
Thank you, Carol, for being a part of CEDAR early on.
Okay, so that's all from our side. Thank you very much for all the participants to be interested in this workshop. Now we have a break at 6 o'clock.
You want to make an announcement for the workshop tomorrow, because it could be interesting for the community.
Okay, good idea. Thank you, Matthias. In the program, in the STC program, we have a last satellite event tomorrow at 2 p.m. 30. We have FAIRware Health solution demonstration. Tomorrow is the final assembly of these European projects, and we would like to share with the scientific community and the research community, especially with health community and fair community, the solution that we have developed and tested in the context of the projects. If you see the STC program on Wednesday, you have the link to send your information, and we can send you the link to connect. Thank you very much in advance if you are interested.
2:30 Central European Time.
Yeah, sorry, thank you. That's all. Thank you very much. We will continue with the STC program in 10 minutes.
Thank you.
Thank
Thanks
you.
all.
Bye-bye.
Bye-bye.
Thank you.